So confidence interval for means, we use this formula, as you can see on your formula sheet. E could either be Z sigma over root n or T S over root n. Okay, depending on what you have. So if you have the population standard deviation, you use Z. If you have the sample standard deviation, you use T. Okay, so you have to be able to decide correctly which one to use in each occasion. So you can see that on your formula sheet. The same formula sheet will be provided for you on the test, and you're also allowed to bring your cheat sheet to the test, just like the last test. So first question here, we have a random sample of 85, n is 85. We have a sample mean of 6.5. And the standard deviation of the population, which means we have sigma, and that is 1.7. So the question here is, what is the best point estimate for the population mean? Point estimate. Anybody ever heard anything like that before? Point estimate. Point estimate is a single value. Okay? When you want to find the confidence interval, which is a range of values, you first find the point estimate and you add and subtract the margin of error from it. So this formula here, x bar plus or minus e, this x bar here is your point estimate. Okay? And e is called what? What's e called? Is the margin of error. Okay? E is called the margin of error. So point estimate plus or minus the margin of error, that's how we obtain the confidence interval. So what is the best point estimate for the population mean? We're talking about what single value can we use to represent the population mean. So for example, if I want to find the average age of all Humber College students, I can find the average age of students in my classes. My classes will constitute a sample of Humber College students, and if I find the average age of all students in my classes, if that number is like 23, that number is a single value. Okay? So we call that the point estimate. We good? So what's the point estimate for the population mean in this question? 6.5 years. Thank you. So the point estimate is just simply 6.5 years. That's it. That's all the question is asking for that. Now we want the 98% confidence interval for the population mean. So in this case, we want the margin of error. The formula for the margin of error here is this. Why are we using Z? Because we are told that the standard deviation of the population was 1.7. We have sigma, so we use Z. What is Z going to be for 98% confidence interval here? What is the Z value? That Z value is called the critical value. So whenever you go to the table to look up a value like that, we call it the critical value. So you have 0.98 in the middle here, which means you're going to have 0.01 in each tail. 0.01 in each tail. So what is the corresponding Z score? So let's go to the Z table and look for the closest number to 0.01. So if you go to the Z table, this is your Z table, you're looking for the closest to 0.01 here. Okay? And the closest you can find to 0.01 here is what? Thank you. So this is the closest you can find to 0.01, 0.0099. And that will correspond to a Z value of negative 2.33, as you can see over there. Okay? So go back here. So which means this value here is negative 2.33, and that value there is positive 2.33. So you're in essence saying that the critical value is 2.33. Okay? So you put 2.33 there, times sigma 1.7 over square root of n, which is square root of 85. And what does that give you? So the margin of error will be 0.43. Thank you. So it suffices to use one more decimal place than given in the question. Okay, so 0.43 is good. In essence, the lower limit of your confidence interval is going to be 6.5 minus 0.43. The upper limit is going to be 6.5 plus 0.43. So I know this is going to be 6.93, and this one is going to be what? 6.07. So that's pretty much how to answer that question. Those are the lower and upper limit of your confidence interval. That's your lower limit, and that's your upper limit. Number 2. So in number 2, we want a confidence interval, a 95% confidence interval for the population mean, and we also required to interpret that interval to state what it means. We're told that the sample mean here is 19.1, which again is your point estimate. N is 9. She selected 9 students, as you can see there. Standard deviation is 1.5. Now, this is going to be sample standard deviation because it's obtained from a sample. It says their average age was 19.1 with a standard deviation of 1.5. So here we're referring to the standard deviation of that sample. Because we have the sample standard deviation, we are going to be using T. So our margin of error formula is going to be the T formula here, S over root N. Okay? We already have S, we already have N. The only thing we need to find here is T. So to find T, we go to the T table. And if you remember, T uses what we call degree of freedom. Okay? What's the formula for degree of freedom again? N minus 1. So N here is 9, so the degree of freedom is 8. So you go to the T table, you're doing a 95% confidence interval. What is your corresponding T value going to be? That T value again is called your critical value. Everybody, let's go to the T table. Degree of freedom is 8, and 95% confidence interval, which is the same here as 0.05. Degree of freedom is 8, so you can see that's your value right there. Or you can trace it down to 95% at the bottom here, 95% confidence interval. The corresponding critical value here is going to be 2.306. Do we all see that? Okay. So it's 2.306. So you're going to throw that into the formula. 2.306 times S, which in this case is 1.5, divided by square root of N, which is square root of 9. What does that give you? 1.15, thank you. So 1.15 is what we have there. And you find your lower and upper limits for that confidence interval. So your lower limit, X minus the error, is going to be 19.1 minus 1.15. And then X bar plus the margin of error is 19.1 plus 1.15. And that will give you, this one here will be 20.25. What? 17.95. Okay, perfect. Thank you. So you got your interval here, and you just need to interpret it. So we say we are 95% confident Okay, so that the, let me make that bigger, that the population mean So population mean of what? Population mean age, right? Lies between 17.95 and 20.25 years. So that's pretty much how we answer that question. So that's a pretty straightforward. You can see in both questions we've answered, all we've needed to find was the t value and the z value. The rest have been given to us. Okay? So you just need to identify what's been given to you whenever you're asked to construct a confidence interval, and then just look up the z value and the t value. So, number 3 wants you to find the sample size required. Sample size required. So if again you look at your formula sheet, you see a formula that looks like this: n equals z sigma over e squared. So that is the formula used to estimate the sample size required. Again, you have your sigma and e. These have been provided for you. See here, they say standard deviation is 2.9 and the margin of error is to be less than half hour, which is 0.5. So again, you just want to find the corresponding z value for 99% confidence. Okay, so confidence is always two-tailed. So I'm going to need your help now. Can you find the critical value z for 99% confidence? Everybody, let's go for a search. Go to the z table and see if you can figure out the critical value z for 99% confidence. Okay, this confidence interval, you can see my picture there, shows you it's always two-tailed. Okay, so you have 0.01 left, you have to divide that by 2. Okay, 0.005 is what you have in the tails, not 0.01. So watch out for that. Confidence interval is always two-tailed. Okay? So 1 minus 0.99 is 0.01, but you have to divide it equally in the two tails. So when you go look that up, let's take a look together. So that is our Z table. We are looking for the closest to 0.005. So you can see it falls between these two numbers. You see that? It's exactly between those two, and it will be between 2.57 and 2.58. So you can say it's 2.575, or if you want to round it to 2 decimals, you can just say it's 2.58. Okay, so our Z critical value there is 2.575 or 2.58. Are we good? So let's throw that into the formula. 2.575 times sigma, which is 2.9 divided by 0.5 squared. Throw all of those in. What do you have? 223.05. So what's your final answer here? You're estimating a sample size. You're supposed to round your final answer to the nearest whole number. What's your final answer? 223, 224. If you write equals 223, you will lose 1 mark. The answer we're looking for here is 224. Always round up to the next higher integer. Okay? It's 224. Always round up to the next higher integer. So first, you want to state the null and alternative hypothesis. Does anyone know what the alternative hypothesis will be for this question? Can someone try? What is the alternative hypothesis for this question? Or maybe the null hypothesis. Can you tell us what each of these will be? Most of the problem statement will be worded in terms of the alternative hypothesis. And as you can see here, it said, can they conclude that the mean is what? Below. Now, the 48,000 is from the sample. So here it said a sample of 60 welders revealed a mean of 48,000. So that is a sample mean. So you have to be able to distinguish between a sample mean, X bar, and the population mean, mu. So we have that information. We also have that the standard deviation is 6,000. Okay? So we have all of that, and we're testing at alpha equals 0.10. Alpha is called the significance level. So the alternative hypothesis, because of the word below here, that will be here, less than 50,000. The mean is less than 50,000. That will be your alternative hypothesis. The null hypothesis will be greater or equal to 50,000, which will be the opposite, going in the other direction. That part is done. Now you want to state your rejection region. In this question, we have alpha equals 0.10. Is it a one-tailed or a two-tailed test? One-tailed. Why? Because it's less. Thank you. Because it's less. It's a one-tailed test. It's only a two-tailed test if it is not equal to. So less, which means your 0.10 is going to be in the left tail here, and you will reject the null hypothesis here in that direction. So are we using Z or T? Z. Z because we know the population standard deviation sigma here. So we're using Z. So what is your Z critical value going to be here? What is your Z value going to be? That's your rejection region. What will your Z value going to be? What is it going to be? 1.28. 1.28. We all agree it's 1.28. So this time is hypothesis testing, and we're not just looking for a general critical value. We're looking for negative 1.28 because it's a left tail test. In essence, you're saying you will reject the null hypothesis if Z is less than negative 1.28. You have to be consistent with the direction of the alternative hypothesis. Okay, so reject the null hypothesis if Z is less than negative 1.28. That's it. That's all you need to do for that second step. So you've stated your rejection region. And after stating your rejection region, you want to calculate the test statistic. So Z equals X bar minus mu sigma over root n. You have all these values already supplied to you. Sigma is 6,000 over root n, root 60. So you compute all of that, negative 2.58 is what you get when you compute that. You will reject the null hypothesis. Thank you. So because we set a decision rule here that says if your Z you compute, your test statistic, is in the rejection region, you should reject the null hypothesis. So our decision here will be to reject the null hypothesis. So we go here. So since Z equals negative 2.58 is less than negative 1.28, we will reject the null hypothesis. And if you reject the null hypothesis, you are supporting the alternative. So can the association conclude that the mean is below 50,000? Yes, because you have rejected this null hypothesis, you are supporting the alternative hypothesis. So yes, of course. So you say you have enough evidence. There is enough evidence for the association to conclude that the mean is below 50,000. And that's it. So that is your conclusion. So decision and conclusion, and you're done with that hypothesis test. Okay, let's move on to the next question. Null and alternative. Anybody want to give it to us? What do you have on this side? Null hypothesis, alternative hypothesis. Go ahead, yeah. What do you have? 203.5. So how would you write it? Mu equal to 203.5. Okay. Does everyone have a problem with that? Why do you have a problem with it? You will say 200. So why would you say 200 and not 203.5? Thank you. So this is what the question is asking us, right? Now, this is a sample value. So we're not testing that. We already have a sample. We already calculated that value ourselves. But because we don't have access to the entire population, we have to do a test for that. So where you really begin is you look at what the problem statement is, different from 200. So you say, oh, not 200. And then you say, oh, the null will be 200. And that's it. That's all you need to write for that. Now, notice that I didn't just write this equal 200. This is what some people write. I'm going to take a markup for that. Okay? Some people just write that equal 200. What is equal to 200? Okay? And if you write this, this is going to make me really mad. I'll take 2 marks off for that. Okay? So make sure you read the question carefully and please write the correct hypothesis, please. Okay, now we want to find the rejection region. So, are we doing a Z test here or a T test? So that's also important because we need to know which table we're going to go to. Are we going to the Z table or the T table? Z, Z, Z. Okay, so we're going to Z. Wow. Population standard deviation. Okay, that's what we're looking for, right? When population standard deviation is given to us, rather than sample standard deviation. So sigma is known. Okay? It means you use Z. Okay? Sigma is unknown. If you have the sample standard deviation, you use T. Okay. So we're doing this test at 0.01. We have 0.01, but it's a two-tailed test. Okay? 0.01 over 2 is 0.005. It's a two-tailed test. So we saw that a moment ago. What do you think the critical value will be again now? 2.575 when you go to the Z table. So it's negative 2.575 here. It's positive 2.575 here. So in essence, you're saying that you will reject the null hypothesis if Z that you're about to compute is less than negative 2.575, or if that Z is greater than positive 2.575. So you have stated the rejection region for the null hypothesis. So you reject here and reject there. Next, the next step is easy. You just need to throw everything in the formula and you'll be on your way. So X bar here is 203.5 minus 200. Sigma is 16 over root 50. Does anyone have a number for that? 1.55. You will not reject the null hypothesis? Does anyone agree with him? He said we will not reject the null hypothesis. You will reject the null hypothesis? Why? It says you should reject here. The region shaded yellow is your rejection region, right? But this number falls here somewhere. Here, this is the region where you do not reject the null hypothesis. So we will not reject the null hypothesis. So this time it is not in the rejection region. So you will not reject the null hypothesis. So your decision is not to reject the null hypothesis. So this time you say you don't have enough evidence that the alternative is true. So you check out what the alternative says and you say you don't have enough evidence to support it. So you say there is not enough evidence to conclude that the mean is different from 200. And we're done with that question. So next one, I'd like you to figure that out, the null and the alternative hypothesis again, if you can. Anybody figured it out yet? The null and alternative hypothesis for that question? And the alternative will be what? Greater than 300, more than, right? Thank you. So more than, the alternative will be more than. The null will be less or equal to 300. Okay? That's all we need to write for that. Rejection region. Are we using Z or T here? T, why? It says S equals 18 watts. You see that? S equals 18. S is sample. So S is given. The sample standard deviation is given. So we are going to use T. Okay? So when you're using the T table uses degree of freedom, and we say for one population means the degree of freedom is n minus 1. What is n in this question? 24, thank you. So the degree of freedom will be 23. Alpha for this test is 0.05. So what is your T critical value? Your T value from the table. 2.069. 0.05 and 23, one tail. 1.714. Are we good? So let's take a look at that together. Very important. So T here, remember your T needs to be correct. 23 is here, okay? And it's one tail. One tail 0.05. Okay? One tail 0.05, right? Yes. Good. So the only time you do a two-tail test if it is not equal to. Okay? Less than or greater than tests are always one-tailed. Okay? Less than or greater than tests are always one-tailed. If it is not equal to, then it's a two-tailed test. So basically, you're saying you will reject the null hypothesis if your T is, and then you follow the direction of the alternative, greater than 1.714. And you actually don't have to draw the curve, but if you have to, it will be on the right here. And that will be your rejection region. And you will reject the null hypothesis here in the tail. Test statistics. So we have a formula here. T is x bar minus mu over s over root n. We have all this information given to us. We have 306 here minus 300 divided by S here, which is 18 over square root of 24. Okay? So I'm going to need help with that number. 1.633, thank you. So you get 1.633 on that one. And we want to see if we should reject the null hypothesis here. So again, you're saying we shouldn't reject the null hypothesis. Okay? So this number here is 1.63. It's obviously not greater than 1.714. So we are not going to reject the null hypothesis. Or you can say because our t is not greater than 1.714 here. So as a result, we don't have enough evidence to support the alternative. So there is not enough evidence to conclude that actual average is more than 300. A range of values that is likely to contain the true population parameters. So that's good. A is number one. That's what we call the confidence interval. Number two, point estimate. What is a point estimate? You're going for C on that one. So the average is that. So point estimate is what is the point estimate for the population mean? It is going to be the sample mean. Number three, the answer there is going to be standard errors. Okay, I'll just explain it to you. Here, what they're saying is you're constructing both 90% and 95% confidence intervals, right? For a particular sample. So what similarities will they have? Now, one thing you know that is that when you're doing 90% and 95% confidence interval, the critical values, the numbers you go up to the table to look at, will be different for 90 and 95. So they will not have that similarities. The interval width, because the interval width uses the critical value, right? Like that. So the interval width will be different as well. And interval width and margin of error are the same thing. So all of these will be different. The only thing that we have in common is the standard error. This guy here is called the standard error, or this one. So that's called the standard error. That's the only thing that will have the same. So the answer is A, number 4. So this is according to the central limit theorem. As sample size increases, the sampling distribution of the sample means approaches a normal distribution. Number 5. Which of these will not be appropriate, will not be an appropriate null hypothesis? You're going for C. Anybody found anything else? B. Anybody found anything else? Huh? E. Anybody found anything else? A is an alternative hypothesis, right? So the question was supposed to be which of these will be an appropriate null hypothesis, and it was supposed to be D. So typo there, but you guys get the idea, okay? So A and C are alternative hypotheses, and they're also even wrong alternative hypotheses, okay? B, null hypothesis must contain equality. It doesn't have equality. B and E don't have equality. So the question was supposed to be, which of the following will be an appropriate null hypothesis? And the answer was supposed to be D. So can you please cross out this not and put BN over there And the answer will be D, please. Are we good? So which of these would be an appropriate null hypothesis? D is the answer. Type 1 error. So let's quickly have a quick overview here of type 1 and type 2 errors. So we say that the null hypothesis is either true or false. And you, as a decision maker, you can either reject the null hypothesis or you could fail to reject the null hypothesis. So we say, if you reject the null hypothesis when it is true, we call that a type 1 error. You have rejected a true null hypothesis. If the null hypothesis is false and you reject it, you have made a correct decision because it was false. And you reject a false null hypothesis. So it's a correct decision. If it is true and you don't reject it, that is also a what? Correct decision because it is true, so you didn't reject it. And if it is false and you don't reject it, you have committed what we call a type 2 error. So type 1 error is like sentencing an innocent person to prison, and type 2 is like freeing a criminal. Okay? Acquitting someone that is actually wrong. So, let's now answer the question. Type 1 error is A is correct. Number 7, type 2 error is C. Now, it cannot be A and B because A and B says they are correct, right? If you made an error, you did not make a correct decision. So wrong. And then B and C, you can only commit a type 2 error when the null hypothesis is false. Number 8. D is good because it says above. Thank you. What if it says below? What would the answer be? I'm hearing A. I'll take additional mark off if you pick A. Okay, so below will be C. That's correct. Thank you. Number 9. So margin of error, again, we know the formula for margin of error is the error part. I know that formula is not written explicitly in your formula sheet, but you need to know what it is. They said a population has a standard deviation of 50. So this is your formula. Okay? And, you know, you have everything except the fact that you don't have the Z explicitly, but they said you're doing your test at 90, you're constructing the interval at 95% confidence. So 95% again means you have 0.95 in the middle and you have 0.025 in each tail, right? That is 0.05 over 2, right? 0.025 in each tail, 0.05 over 2, right? What is the Z value for it? 0.025 is 1.96, thank you. You go to the Z table and you're looking up 0.025. So let's do that very quickly again. So you go in here, you're looking for the closest to 0.025. It's going to be this guy over here. So you can see it's 1.96 there, negative 1.96, okay? So, going back here, you throw it in there. Sigma is the standard deviation. It is 50 over square root of 100, and the answer is 9.8. Okay. Confidence interval, the critical value if you're doing a 92.5% confidence interval. Anybody want to try that? 92.5 confidence interval. The critical value again is the number you go in to look for in the table. What is your Z value if you have 0.925 in the middle there? 1.78. So what did she do? 1 minus 0.925 gives us what? 0.075. So divide that by 2, you get 0.0375. Do a reverse lookup for 0.0375. It gives you 1.78. So of course it's negative 1.78 here, positive 1.78 here. How did she get it? Let's go to the table very quickly. Z table, 0.0375 is sitting right here for us. See that? So 8 up here and 1.7 negative there. Okay, let's move on. You constructed a confidence interval at 95%, but you changed your mind and you said you wanted a 99% instead. Oh, I skipped 11. Okay, sorry, 11 before 12. 11. Margin of error. If you increase the sample size, what will happen to your margin of error? Increases. So let's look at the formula first before you say increases or decreases here. The formula for margin of error is this: E equals Z sigma over root N. N is your sample size. If you increase this sample size, N, what will happen to E? If you increase N, what will happen to E? If you increase the denominator of a value, what will happen to that value? It will become smaller. You're dividing by a bigger number now, right? And of course, in stats, when you use a bigger sample size, you reduce the amount of error you're making. You understand? Okay? You increase the sample size, you make less error. You use fewer people, the result could be biased. The more people you use, the larger your sample size, the more representative of the population your results will be. Your results will reflect the population more if you include more observations in your sample. So error becomes smaller as sample size increases. Number 12. If you go from 95% confidence to 99% confidence, what happens to that interval? It becomes narrower. It becomes wider. Thank you. If you go from 95 to 99, so that's 95%. This is 99% now. Right? So you can tell that your Z value or your T value increases. And if your T value increases or Z value increases, your margin of error also increases. So at the end of the day, the interval becomes wider. Okay? And if you go the other way, the interval becomes narrower. Interval estimate is also called confidence interval. An interval estimate is also called confidence interval. And what do we use it for? So all the confidence interval we've constructed, we say, okay, we have a lower limit of 23 and we have an upper limit of 28. What are we trying to capture in that interval? Population parameter is what we're trying to capture. Okay? Remember, to obtain this interval, what we used was a sample. We use a sample and we obtain this, but we're trying to say that that sample will very likely contain the population parameter that we don't know, okay, at some level of confidence. So that's what we're trying to do. I'm going to skip 14 and 15. I'll post the answer. Let's move on to 16. If the alternative is true, it means the null is what? The null is false or incorrect. Thank you. Right? That's what it means, right? So what do you think the answer to 16 would be? If the alternative is true, it means the null is incorrect. So you have just rejected a false null hypothesis. Right? A null hypothesis has been rejected, and that null hypothesis is false. What's the answer?
D.
D. You have just rejected a false null hypothesis. So you have made a correct decision. There is no error there. Remember, the null and the alternative hypotheses are mutually exclusive. It means if one is wrong, it means the other is right. It's either one or the other. 17. So here, we're looking for the rejection region. Obviously, it's going to be on the T table because all our options are T here. Alpha is 0.05. Okay? Alpha is 0.05. What do you think your rejection region will be for this question? Number 17, C is correct. So how did she get C there? Alpha is 0.05. Remember, you have degree of freedom, which is n minus 1. So degree of freedom here is going to be what? N is what in this question? 20. Thank you. So degree of freedom is going to be n minus 1, 19. So you go to the table, and is it a one-tailed or a two-tailed test? One-tailed. Why? Because it says less than. Thank you. So it's a one-tailed test, so 19 and 0.05. And because it's a left-tailed test, that's why it's negative. Okay? Your rejection region must be consistent. Many people will pick A. That's what people usually pick for that question. It has to be consistent with your alternative hypothesis. Very important. So the answer is C. Number 18, right-tail test. What is your Z value? So right-tail test just means this is a one-tail test and you have 0.063 here. What is that Z value going to be? Normally, when you go to the table, if you look at 0.063, it's going to be in the negative side. So you want to subtract that from 1, it will be 0.937. So you do a reverse lookup for 0.937 in the Z table. Like I said, if you look up 0.063, it's just going to give you the negative version of that number. 1.53, thank you. Number 19. Number 19, this is your formula for finding Z. For finding N, rather, sorry. You guys have this formula. So, to find that sample size, which of those four is not needed? C. C says the confidence level. C says the confidence level. How do you find Z if you don't have the confidence level? A, of course. There is no sample mean in there. We don't need it. Number 20. Standard error of the mean. Standard error of the mean. So like I said before, standard error of the mean is this guy here is sigma over square root of n or s over square root of n. That's what we call standard error. Standard deviation is 27 and sample size is 81. Okay? That's it. You're done. The standard error of the mean is what? 9. Number 21. Point estimate is correct. Number 22. So you have a confidence interval from 72.5 to 83.9. What will the sample mean be? So remember, to obtain this confidence interval, we use the sample mean, whatever it was, plus or minus the margin of error. Right? That's how we obtain the confidence interval. So this is your upper limit, that's your lower limit. How do you find the sample mean? Just add the 2 and divide by 2. The sample mean will be in the middle, right? Okay, so that's all you need to do. So upper limit plus lower limit divided by 2 gives you your sample mean, which is C. What if I ask you to find the margin of error? Thank you. So you can take the sample mean minus the lower limit or the upper limit minus the sample mean. Remember, the sample mean is in the middle. 23. So you're told that the standard error, so standard error is, like I said, sigma over square root of n, right? So 6.25 equals sigma, which is 50 over square root of n. So question is, what is n? Can use trial and error. Or you can do basic math and find your sample size depth. Okay? 64? Thank you. So that's going to be it pretty much.